So I found this data on plug-in electric vehicle sales in the US, 2010 through 2019. Now I can clearly see they have some numbers for 2012 through 2019. It starts to go up, so part of this looks kind of exponential. I'm wondering if it might look linear too. 2011, they don't have a number. I didn't see it on the page. But it looks like they're showing there's a growth rate of plus 75% from 2011 to 2012. So if I back off that 75% from the 55%, I think I'm going to get about 30. And that's not 55 cars, that's 55,000 cars, annual in thousands there. So I recopied those numbers into a spreadsheet. And I'm going to do a couple different versions. I'm going to do this as I'm going to guess it's exponential first. Let's just look at the graph. I made an extra column here. So I typed my 2011 to 2009. For our models, it's best to have a year 0. So I'm going to say years after 2011. And I typed the 2011 and 12, but here I did a formula where I just said take whatever year it is and subtract 2011 to get the years after. And I just filled that formula down. And that calculates those numbers. Here, I typed in their numbers, 55, 96, 119, and made them thousands. And I made a calculated guess that 2011 was 31. If you found the data, you might feel free to leave that one out because they didn't explicitly state it. But I'm guessing at it because they had a column in the graph. I'm going to graph these two columns here to make sure it looks like theirs. So I'm going to insert a chart. And okay, I want a scatter plot because I want to use the points. And yeah, it's kind of linear at first, then it jumps and settles down. So I'm going to think about a line through that, but it also looks kind of exponential, ignoring the drop over here. So this could kind of go either way in my mind. Let's look at a bar chart of that, see if it looks like theirs. Yeah, that's what their chart looked like. Okay, so I'm looking good there. So I'm going to go back, do a scatter. And then I imagine holding up a piece of paper to this and guessing at a couple of points. If I were going to do a line, I would guess at this point here and that point there. The line hits, and then these 3 points and that second to last would be above, and these 3 would be below, kind of splits the difference. If I wanted, and then I can use those 2 points to find the slope and the y-intercept. If I'm guessing it's exponential, then I have to guess at a growth rate through here. So I'm going to delete the graph and show you how I would guess on that. And the key to that is if you think about just simple like interest increasing by 2% every year, if you're always increasing by 2%, then when you take 2 consecutive periods and you divide them, this divided by that, and then you repeat that calculation, always dividing the one by the one before, you're always going to get the same. This is my growth multiplier, the 1 plus R. So in this case, my R would just be equal to 1 minus that division. Oops, apparently I missed the minus. So, oops, no, I want that -1. Wrong order of operations. Equals this -1 gives me the percent change. So there's my 2% increase in my account. Growth multiplier here, growth rate there. So this right here is my 1 plus R. And 1 plus R is always going to be some period divided by the period before. Take 1 away from that and you get the growth rate. So I'm going to try that with the electric vehicle numbers, see what I get. And if it is truly exponential, then I should get about the same multiplier each time. So here, let's call that multiplier. And I got to start on the second one, equals this number divided by that number. And then, yes, I do want to fill it down. If I want the growth rate, R, from each of those consecutive periods, I would just go the multiplier -1. Yeah, let's fill them down and let's call them percentages. So I can see at first it went up by 77%, up by 74%, up by 23, down 3%, up 36, up 27, up 79, down like 6%. So it bounces around a little bit. They're not all the same. You could guess at some kind of average of those. Average. And Spreadsheet has an average calculator called average. And I just highlight the numbers and hit enter. And it says on average, it was growing by like 38%. All right, let's try that. Okay, so I have a guess that the average rate is about 38%. I'm just gonna move this out of the way. So to test that, I'm gonna add a new column next to the actual numbers. I'm gonna call that my equation column. And in the equation column, I'm gonna type what my equation is. So I think my growth rate is about, as a decimal, let's make that just a decimal number, about 0.39. So then my equation would be the starting amount equals 31,000 times parentheses 1 plus that number, which would just be 1.39. Oops, I got an extra 0 there. And I don't really need the parentheses there. And then I would raise it to the power years after. And now these are consecutive years. If this went every 10 years, like some population data is, then you would have to do something like parentheses this divided by 10 if it was jumping by 10 years. But mine just jumps by 1 year, so I could divide by 1 in parentheses for the power, or just make it the power simply. And then I do want to fill that down. Now to see if that's reasonable, I mean, I can just kind of look. So let's format those with commas so we can better compare. Number, back off a decimal, 157, 160, 200, 223, 358. Hey, that doesn't look too bad. I can graph that by doing all 3 of them together. I'm going to ignore the actual year, make a graph, and I want it to be scatter. So my blue is the original, my red, hey, that's not bad. That looks pretty good. So I have a model here, and then I can use that model to make a prediction. So I might make a prediction for 2025, and how many years later that would be? That would be 2025 minus 2011. And then I can just fill this formula for the equation down to make a prediction. Ignore that one in the middle. And my prediction would be if it keeps growing at 39%, then in 2025, we would expect to see in that year 3 million sales of electric plug-in vehicles. Seems a little high. Okay, so is it going to continue to grow exponentially? Probably not, but that's my guess. If instead of going for an exponential model, you say, well, I think the data is more linear, then let's delete that. You would have to graph the data, and I recommend graphing it as points. And if it didn't pick points for you, then scroll down until you see the scatter plot. And then you have to line up a piece of paper there and say which 2 points best fit the pattern. And my guess is this last point there, so that 8 years later, and then this would be 3 years later. So I would use those 2 to find my line. And to find the equation of a line, you need your slope, which is rise over run, to find the slope. And then you can find the y-intercept, b, by just considering y equals mx plus b. If we plug in a y and an m and an x, we can just subtract the mx over to get the b. So my claim is that if I just do a subtraction there, then that's going to be how I calculate b from one of these points. So I'm going to do those right now. So I think I'm going to use this year, let's highlight it, and 8 years later. Those are the 2 I picked on my graph. So to find the rise, I just subtract the y values. So this minus that. To get the run, you can use a regular calculator too to do this. To use the run, I'm going to take this number minus that number. And then the slope is just the rise divided by the run. To get the B, I just need to pick a Y value and do the minus MX. So let's say I'm going to pick on that one right there. Let's make that like a green color. Match this here, green. All right, so that calculation would just be equals the Y value minus the slope M times the corresponding X value. And so I get 1100, negative 11,000 for that one. So my equation would be from these two numbers. So to test that equation, I'm just going to type it in here. It's equal to my slope, just type the slope, if you want this to work right, times the X value in that row that you have to click on. And then I'll do my minus 11,800 and fill that down, yes, or you can just click back on it and fill it down. And then I'm going to regraph to see them together. So I'm just going to delete that and see what they look like together. Graph, scatter, and red is my line. It cuts through the points. That's not too bad. So then I can make a prediction here too, like 2025. How many years after 2011 is that? And then make that prediction. And so this one guesses that there's going to be 598,000, 599,000 electric vehicle sales in 2025. That one seems a little more reasonable than the exponential one. Okay, so you don't need to do both exponential or linear. You need to do one or the other, whichever one you think is best for your data. Hope this helps. Have a good day. See you soon.